All right. So we have a test next class, right? Yes? Okay, so we're going to finish up what we need to finish up, which will be, we did toolbox of functions, transformations last time. We're going to do 2.8 algebra and composition of functions. That's not going to take a lot of time. And then I have a review for us to go through for the test. And then after that, I'll cut you loose. So it might be a short day today. Sorry. But we won't start new material. And then what we'll do is we'll come in, we'll take the test first thing. After the test, we continue on into chapter 3. All right.
Are you available for tutoring prior to the test?
Yes, I'm always in my office before this class from, today it's from 12:30 to 2. So, okay, so I'll be there Thursday, same thing. All right. Any homework questions? We can start with that. Questions on homework? Yes.
Page 201, 53.
Page 201, number
53.
53. Determine the domain. That one?
Yeah.
Okay. So you're given u is equal to v minus 5 over v squared minus 18. And you're asked to find the domain of this. So domain, there were two things we were concerned about. Division by 0, right? And square roots of negative numbers. So we don't have a square root, we don't have to worry about that. But we could possibly get division by 0 here if this denominator is ever 0, right? So what we need to do is ask ourselves that question. You know, when would this be 0? Or in other words, we don't want it to be 0, right? You can look at it two ways. We can say, when is it 0? And then figure out what those answers are and say, okay, throw those out. Or we can say this, we don't want it to be 0. So what can we do here? Any ideas? You can add 18 to both sides of the equation. That would be okay. If you do that, then how can you get v by itself there? Not v squared. Square root both sides. So you can take the square root on both sides. Now you have to remember that if you come in and you take the square root on both sides of an equation, you must always look at both the positive and negative answers. And that just happens to be because anytime you square a number, it's positive, even if it started negative. So you have to look at the possibility that this answer could have been negative. Right? So square root of plus or minus square root of 18, and the left side of this will become v. So v cannot be equal to plus or minus square root of 18. Now my guess is that the back of the book doesn't have square root of 18, right? 3 root 2, right? So all they did was they said, okay, 18 is 9 times 2, right? And then you have properties of roots that allow you to split that up into 2 separate roots. And then the square root of 9 is 3. So you get 3 root 2. Now on a test, I'll take square root of 18. No problem. Okay? This is just simplifying it a little more. It's not wrong. It's just good.
Remember,
Now, we're not done though, right? We're not done because we need the answer in interval notation. So think about what we're saying here. If you look at a number line, if this is 0, we're saying that our v cannot be square root of 18. Right? I'm going to leave an open circle here. We cannot be that, and we can't be on the other side negative square root of 18, right? Can't have those. We can have anything in between them. We have anything to the left and anything to the right. So remember we talked about when we do interval notation, we want to read it like a book from left to right. And so how could I say everything to the left of negative root 18? So I start negative infinity, always put parentheses on that. All the way until I get to where? Negative root 18, and I do not want that number, right? So I put parentheses. Okay, that's the left interval over here. Now everything between here and here. So I want to start where? Negative root 18 again, right? I do not want to include it, so I put parentheses. I want to stop at positive root 18. I don't want to include it, so parenthesis again. What do we put in between those? U symbol, right? Union. Then over here I'm going to have another interval, right? The other side of this. So union again, and then I say everything from root 18 on forever. Does that make sense how that those intervals are written? It's like a book from left to right, negative infinity all the way to here. Jump over that point, everything in between, jump over, everything after. Now, does the book write it that way? Something close?
Yeah, it's close to that.
Close. Let me see what they have. They just used 3 root 2 instead? Okay. Does that address the question? We good? Okay. Anything else? 55. So that was 53. Okay, yeah, no, they do add one thing in here. I will put it here, even though I would not take off on your exam if you left this out. V with this little E in front of it. Okay, what that says is that we were all trying to figure out what you can and cannot plug in for V, right? V was the variable. And so this just tells you that V is an element of one of these sets. If V comes from one of these sets, so if V is a number somewhere in here, we're good. All right, that's what that means. So V, an element of that. On the test, that's fine. I understand that you mean you're talking about the variable V. Okay, so 55 now. Y is 17/25 x plus 123. So what about this one?
Isn't it all the numbers?
Yeah, it's a line, right? That's right, because this is an equation, it has 2 variables in it, right? X and Y. Both of those variables are raised to the first power. So this is a line. We can even look at it as y equals mx plus b. So if it's a line, which I don't really care for us to draw it, but you could draw this line, right? And if you look at it this way, domain, remember we look on the x-axis, we look up and down. Say, do we hit somewhere? Yes, 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 everywhere, right? Look up, down, we're going to hit somewhere. So domain's everything. Another way to look at it is, do you have a fraction here? Like, do you have x in the denominator? Where does this x live? That's the same as x over 1, all right? And the 17/25 is in front of it. So the x is on top there, so we can't ever make that 0 on the bottom. Does that make sense? Having 0 on top is okay, just not on the bottom. So we don't have division by 0, and there's no square roots. So if there's never a problem, then we can plug anything we want in, so we say all real numbers. So in interval notation, the answer would be everything, right? And that's how we say everything in interval notation. And technically, back in the book, x is an element of that set. Okay, anything else? No? Okay, we left off last time we were doing transformations, weren't we? So why don't we go back and do a couple? Did anyone have any problems with any of these if you tried them homework-wise? I gave you some where they were like match the graph, and then the other ones, what, like 75 through, what did I give you, 75 through 87? Or 80? Through 87 odds? Okay, so let me just pick one of those, just so we can kind of warm up a little bit. How about number 77? Is h of x equals negative, in parentheses, x plus 3 squared, and then minus 2. And the instructions here are to clearly state and indicate the transformations and identify the location of the vertices, initial points, and/or inflection points. Now, the only thing I wanted you to do was do what we did in class, basically. Move things around. Right, just show me the transformation of this. So when you look at this, what is the toolbox function we know it's going to look like? X squared, right? X squared, because we have something, here's our x, it's got a number next to it, but basically this is like an x squared. So I know to start with, it's going to look like this u, right? That's x squared. Now the question is, what are the transformations? So let's list out the transformations, and let's list them in the order that they have to be done. Because remember we said last class, the order matters on this, right? So what would be the first thing that needs to happen to that graph?
Anything that's in the parentheses.
Within the parentheses, plus 3 inside tells you which way.
Left 3.
Left 3. So I'm going to go left 3. I have no idea what happened then. The neurons just didn't fire correctly. Left 3, right? Opposite of what you think. So that happens first. I'm done. The squared happens next, but that's what gives me the shape. Okay, so I don't worry about that. Now, do I do the -2 or the negative out front? Negative out front, because what's the operation right here? What's really that operation? Multiplication, right? That's multiplication. And doesn't multiplication always come before subtraction? So that's why I'm doing that next. So I do that multiplication. What does negative in front of the function do? Reflects it over which axis? X-axis. Reflect x-axis. Okay, so that's from the -1. And then now we move outside of all this and go down to. All right, so those are the transformations. So let's go ahead and do those. One way you can do it, remember I always said look at that point. That's always going to be there for all these pictures. And just move that point around. And then do your reflections also. So first, let's go left 3. If I just mark this 1, 2, 3, that point comes here. Okay, that's my first transformation. Now my reflection over the x-axis is going to take this and just make it open down instead. Notice the reflection does not change that point. It stays there. And then, whole thing down 2. So if I mark out 1, 2, here we go. It would be there. And now I'll draw it solid. And that's all I'm looking for. Okay? Now, because of what's going to be coming today with the test review, I want to ask you an additional question here. 2 questions. What's the domain? What's the range of this function? So let's talk domain first. There's 2 ways you can do domain here. You can do it visually, or you can do it by looking up here. The easier way, I think, is the visual. Although with this problem, it may not be so bad because we don't have fractions. We don't have square roots, right? So we should always be able to plug a number in and not have any issues. We can also see that here, that if we move along the x-axis and look up or down, in this case down, we'll always be hitting the graph somewhere, right? Eventually, I mean, this keeps on going, gets wider and wider, so eventually I would hit that down there. So for every x value, there's a corresponding part to the graph. Make sense? So domain would be all real numbers. I told you last time you could write that. You could also write all real numbers. I'll take any of those. But this one, I like more. Just because that's interval notation, that's what all your other answers are supposed to be. All right, what about range? Range is not easy to find, not as easy to find looking at this. But range becomes very easy to find if you look at the graph. So what we do is we look on the y-axis instead of the x, and we look left and right and see if we hit the graph. So up here, if I look to the left, do I ever hit that graph? To the right, do I hit it? No? If I keep doing that, as I move down, I'm never hitting it until I get to what point? -2. That's where I first start hitting. I'll hit it right there. And then as I go down further, I hit it over there, don't I? Doesn't matter that I hit it twice. I do have graph over there, right? And that'll go forever, won't it? That means I need to somehow say forever down, which is -infinity, right? Down there. And the way we write our interval, if it's an interval on the x-axis, we read left to right. If it's an interval on the y-axis, we read down to up. So I need to go from -infinity to -2, right? Now, -infinity, I always put a parenthesis, right? Does this graph ever achieve the value -2? Is it ever that value? Yes, there's a dot right there, isn't there? So I need to include -2 as part of my range. So I put a bracket instead of parenthesis. We good? Okay.
I have a question.
Yes.
You did ask for inflection point, but that's just the -3 and 2, right? Inflection point?
If it had an inflection point, we didn't talk too much about an inflection point because we skipped 2.5. 2.5, they talk about inflection points. I'll tell you what an inflection point is since you're asking. But this is beyond what we need to worry about for the test. If you have a graph that does this, all right? And next to it, I'll put another graph. These are two of our toolbox functions. This is an x squared that's been moved down, right? Open down like this. This is an x cubed, all right? Now I want you to notice something about the x squared function. If I come in here and I draw a person, right? That's like a sad face, right? See the sad face? Not very happy person. Okay, over here, is this a sad face? No, but there's a point right here where this side of it is a sad face, right? Like part of the sad face over here. And this part over here is part of someone's happy face. I know this is a real cheesy way to approach it, but do you see it? It's like this is half of a smile and this is half of a frown. Anywhere you go from a frown to a smile, the point that it switches, so it'd be the corner, that's called an inflection point. Now, if you have another function that goes this way like that, now you go from smile to frown, that's an inflection point. An x squared function goes from frown to frown. It does not have a switch, a change there, right? It's always a frown. There is no inflection point. That's just to kind of address your question.
Yeah. The reason why I asked is it asked for it on me.
Yes. I thought that when I assigned those, I thought I had said verbally, just do what we did in class for those. Just move them around. But sorry for the confusion. I'll be more. I'll clarify more next time. Okay, we good? Shifting? We want to see any more shifting? So I've decided to skip piecewise functions, and I'm not quite sure if that's the best idea, but historically, that section 2.7 is a real pain, and since a lot of you are not doing any more math, I'm okay with not doing it, all right? They're actually, I'll tell you a little bit about what they are, but Anybody here pay their own utilities? CPS? Okay. Or you pay for your own water? The way that it works usually is you use, let's say, electricity, right? What happens is they say, okay, anywhere between 0, and I'm just making up a number here, 100 kilowatt hours. That's the measure. That's how they measure how much energy you're using. They say, oh, if you use between 0 and 100 kilowatt hours in a month, we're going to charge you, and again, I'm just making numbers so they're easy. We're going to charge you $1 per kilowatt hour, right? So if you use nothing, you pay nothing. If you use 100 kilowatt hours, you pay 100, right? So, but then they say, okay, if you use anywhere between 101 to, let's say, 200, now we're going to charge you $2, right? So what happens if I use 101 kilowatt hours? How much do I pay? Think about it. So how much do I pay for the first 100? I pay $100 for the first 100, right? Now anything over that, I pay now $2 per kilowatt hour. So if I use 101, I pay $100 for the first 100, and then I pay $2 for that extra one. So I would pay $102. Does that make sense?
Yes.
And then what they say, they tier their prices. So if you go now between 201 and 300, then they say, all right, now we're gonna charge you $5. And it's the more you use, the more you pay. It's really like this for water, especially in Texas. If you use within a certain amount, not much water, they don't charge you a whole lot. But once you start like going way past what the average person uses, you pay a lot for it. Okay? Now, if you were to look at this, number one, or $1 for any value between here and here, couldn't you look at that as being like 1x? So x is how much I use. If I use 50, right, then it's $50. Doesn't this graph look more like 2x? And then this graph looks more like 5x. Does that kind of make sense? So if you were to look at your costs as a graph, it would look like 1x has a slope of 1, and then it would switch after 100. It would switch to a steeper slope, and then once you get past 200, it would go even steeper. Does that kind of make sense? So we call this a piecewise function. For a certain part of its domain, it acts like one thing, and then once you get to another part of its domain, it switches, and then you get to another part and it switches again. So each piece of this function is different, and that's called a piecewise function. So they're very applicable to real-world situations, but in this class, we're just going to jump over that. Okay? You all right with that? Any complaints? Any objections? All right, so we're going to go to 2.8. The algebra and composition of functions. So when we use the word algebra, okay, the algebra of functions, what we're really talking about is the 4 operations that you learned in your life as you grew up, right? First thing they've ever taught you was addition, right? Then subtraction, and then multiplication, then division, right? So you would take 2 numbers, add them together. You take 2 numbers, subtract them. 2 numbers, multiply. 2 numbers, divide. Now what we're going to do is the same thing: add, subtract, multiply, and divide. But instead of having numbers, we're going to take functions and do that. So take a function, take another function, add them. What does that mean? What do you do, right? And so we're going to have to look at the 4 arithmetic operations on functions. And then we're going to learn that there's actually a 5th operation on functions that you do not have on numbers, and it's called composition, right? So that's where we're going with this section. So first thing we're going to talk about is addition of functions. So to start this out, let me write down, let's say you are given two functions, f comma g. This means f and g. So I've given you two functions, right? Then how do I tell you I want you to add them? Right? On a test, right? I give you two functions. How do I tell you I want you to add the two together? I can't come around and be like, hey, on that number 3, add those, add those. I need some way of writing it in notation so you understand I need you to add those two functions together. So here's how I do it. I write in parentheses f plus g, and then this. Now I want you to compare that to what these two are. If I write this function, this is the way I write it, right? F of x and g of x, right? That's the way I write those. And f was the name of this function, wasn't it? We talked about this is the name of it. The name of this function is g. This new function that I want you to create is adding those two together. This is its name. See its name right there? F plus g. So this is purely notation. Now what it means is to take f and multiply it times g. Okay, so if you see this, did I just say multiply? Sorry. Add. So you add the two. So let's do an example. So as an example, I say let f of x be equal to 3x cubed minus 4x plus 7. Let g be equal to 2x to the 4th minus x cubed plus x minus 4. And now I ask the question, okay? So I've provided you two functions, and now I'm going to ask you to find this. Right? That's the way it would appear on a test, just like that. So what you need to know is what to do with this notation. So here comes your answer. You say, well, that's equal to my f function plus my g function, right? That's all it means. So just write down whatever f is, then a plus symbol, and then write down what g is, and then do what? Combine like terms, right? Collect all your like terms, and you are done. That's it. So writing down f, 3x cubed minus 4x plus 7. Now here's my plus, and then I have 2x to the 4th minus x cubed plus x minus 4. I will stress to you again, this right here was g, right? Here's our plus, and this was f. The reason why I'm showing you that is because subtraction's a little tricky, so I want to make sure you understand all we did was wrote down f, a plus sign, and then g. When I combine things together here, let's put it in descending order, highest power of x down. So what would be my first term? 2x to the 4th? Okay, so that equals 2x to the 4th. Okay, how many x cubes do I have? 2, right? I have 3 of them there, and then there's minus 1 of them here, so 2x cubed. How many x squareds? I don't have any x squareds, do I? Okay, how many x's? It's negative 3. And then constant term, 7 take away 4, so 3. That's it. You're done. Domain? What's the domain of this? See any fractions? See square roots? All real numbers. I didn't ask for it, but I could, couldn't I? Okay. Now, subtraction is exactly the same thing, except I'm going to use minus sign, right? So subtraction works this way. If I write f minus g like that, then what this means is you take f of x and you subtract g of x. Now, be very careful. This must distribute. If you have a negative sign, right, we always said if you have a negative sign in front of a parenthesis, you have to distribute that through, don't you? Well, this, whatever g is, if I want to subtract g, that means I want to subtract every single term of g. So you'll always want to make sure you put g in parentheses if it has more than one term. And then you'll change the signs as you go through the negative. So let's do the exact same problem, okay? The same two functions I gave you a second ago, all right? Same two functions, I just don't want to have to write them down again. But I want you to do, I want you to find this. Now, I did something there. Do y'all notice it? I switched it, right? I put the g first, then the minus f. Do you think that that matters? Doesn't matter. Is g minus f the same as f minus g? Is 5 minus 4 the same as 4 minus 5? No, right? This is 1. This is negative 1, isn't it? Now, addition doesn't matter, does it? 5 plus 4 is the same as 4 plus 5, but with subtraction it does. And so whenever you're given this notation, whichever function is first here goes first, and then the f would come next. So I just want you to see that this is the definition, but if I give you the problem like this, you need to realize that the g is going to have to go in front of the f. All right? So what was g? Because I can't get back to it now. It's in my brain. It's gone though.
2x4.
What was g?
2x4
2x to the 4th.
minus x3
Okay.
plus x. Subtract 4.
Okay. That was f. I mean g. Everyone agree? Now I want to subtract. I'm going to put it in red. I want to subtract what?
3x3
Okay.
subtract 4x plus 7.
Okay, is that the way it appeared? That's the way I wrote it down, right?
Yep.
Okay, this is not correct if I write it like this right now. I need to put this in parentheses. Because the minus is going to have to go through to each one of these. And that's the biggest mistake I see students make. Is that they'll put the minus here, they won't put this, and then they'll just start collecting like terms. You must have the parentheses, you must subtract all of f first before you start putting things together. Make sense?
Yeah.
So let's go ahead and distribute that negative through. And distributing a negative through has the effect of changing all the signs, doesn't it? If it was positive, it's now negative. If it was negative, it's now positive. Positive, negative. And now you can collect. So I will have 2x to the 4th minus 4x cubed plus 5x minus 11. Box it up. Questions? All right, so that's addition, subtraction. So we still have multiplication, division. Okay, for multiplication, how do I tell you to multiply two functions? Well, you would think I would just do this, right? Like f and then put like times g or something like that, or a dot between them or something to let you know multiplication. Well, it turns out we don't. We just put fg, and it's understood that it's multiplication. And all it means is you take f and you multiply it times g. Whatever those two functions are, you multiply them. Now again, I'm going to say be careful here, because if f has more than one term and g has more than one term, you're going to wind up doing like a FOIL type thing or like an expansion, and it can get a little bit tricky. So let's do an example. You'll see what I mean, all right? I'm going to give you two different functions. I don't want to use those again. So new function, so I'll put a new example here. Let's let f of x be equal to x squared plus x minus 4. Let's let g of x be equal to x squared, 2x squared plus 3. Okay, the instructions here, find this. Would it be different if I put G than F? Ask yourself this question. Does multiplication, can you flip multiplication over and does it stay the same? Yes, right? 3 times 4 is the same as 4 times 3. So this is kind of like addition. It won't matter which way, but I'm just going to go in the order that it was given. So I'm supposed to take my f function. What is my f function? X squared plus x minus 4, right? I need to take that. I need to multiply it, right, times the g function. So times, here's the g function, 2x squared plus 3. Is that okay to write it just like that? No. Because all this is doing, if you write it like this, the only thing being multiplied is negative 4 times 2x squared, right? That's the only thing that's being multiplied. I need the whole thing over here to be multiplied by the whole thing here. So I need to put a set of parentheses and a set of parentheses like this. So there's my f, and there's my g, and they are being multiplied. See the difference? Critical difference there. And the question now is, do you know how to multiply that? So I'm trying to figure out this. X squared plus x minus 4 times 2x squared plus 3. How many of you were taught or learned at some point in your life that thing called FOIL? Y'all like that? Y'all like FOIL? Let's see. Let's do a quick review of FOIL, all right? I'm just going to do something over here. If someone gave you x plus 1 times x minus 3, at some point maybe some teacher taught you to use FOIL, which meant what, first, outer, inner, and last, right? Did y'all like that? That's cute, right? FOIL, that's cute. So you get the first two terms, right? First two terms, you multiply those first. And then you do the outer two terms, which are these two. Then you do the inner two terms, which are these two. And then you do this right here, right? But why can't we use FOIL here? There's 3 in the first and 2 in the second, right? Okay. I know you're tired. I can tell you're tired. All right, you okay? All right. I just don't want you to miss this part because this is important if you don't know how to do this. So how do you do it? If FOIL won't work, how do you multiply those two? Anyone know?
Can't you just distribute? Normally you would multiply the x squared by 2x squared plus 3 and multiply the x by the 2x squared plus 3. And then
That's the correct systematic approach. So let me go back over to FOIL and let's act like no one ever told you this. I don't ever teach my students FOIL. Because although it's cute, it only works when you have 2 terms times 2 terms. And that's kind of like only having a key for one door, you know? I mean, it'd be better to have the whole keychain or something that works on all of the doors, right? So this is, although cute, FOIL is not useful there. But watch what happened. When we said for first, right? When we did FOIL, we did this one and we did times that, right? And then when we did O for FOIL, right? Outer, we did that, it was basically that first one again times this one, wasn't it? And then we did inner, which meant that we went to this one and we did this times this, yes? And then after that we did last, which was this times this. I want you to see we can do that same systematic approach here and get the result. So what I'm going to do is I'm going to start with this one right here, the first guy here. And what I will do is I will distribute him through everything on the other parentheses. Okay, so it's kind of like you start here, go there, there, right? Start here, go there, there. Once you've exhausted this one, it's distributed to both, you move to the next one. The next one is x, right? Now I pass x through the other two like that. Right? I've done the x, I move to the next one. The next one would be -4. -4 passes through. And once you've gone through all of them, each one of these is distributed through here, you're done. Do you understand that? So if I would have had 3 over here, 3 terms, and 3 over here, then I would have gone the first one here, here, and then to the third term. Then I would have moved to this one, it would have gone here, here, and then to the third one. And then this one here, here, and then to the third one. And if you use that approach, you could do, 10 terms times 30 terms. It would be long, but it could be done. See what I'm saying? Okay. So let's go ahead and expand this out. This is called foiling, that's called expanding. So let's expand this. We do the x squared times the 2x squared. What's that? 2x to the 4th. Then we do x squared times 3 plus 3x squared. Okay, I've done the red part. Now the blue part. X times 2x squared. 2x cubed. X times 3, 3x. All right, we're getting there. Now -4. -4 times 2x squared. -8x squared. And then -4 times -3, -12. Okay, we've done the expansion. All we have to do now is collect like terms. I'll point something out here. How many terms were in this right here? How many terms were there? 3. How many terms were here? 2. How many terms did we get when we multiplied this all together? 6. 3 times 2 is 6, right? If we had 3 terms here and 3 terms here, how many would we have? 9. Then we'd have to collect them together. But that's kind of something, when we did FOIL, right? 2 and 2, we should have got 4 terms, which is what always happened. Yeah. All right, this will give us 2x to the 4th. Descending order. Plus 2x cubed. Minus 5x squared. Plus 3x minus 12. Domain, all real numbers, right? So I guess there's 2 important things that I want to make sure everyone understands with the multiplication. Make sure you put f and g in parentheses separately. And then make sure you kind of get the FOIL idea out of your head, because I doubt you're going to see that on a test. It'll be something more like that. All right, no questions? Division. Division. Now with division, the notation that we use is this. That's the notation. And as you might suspect, it means take the f function and divide it by the g function. And we have to add one little additional note out here. So long as that g function is not what? 0, right? Because if the g function is 0, then we can't even talk about this, can we? All right. Now, fortunately for us, as you're going to see, division, I think, is the easiest when it comes to like writing it out, but it's a little tricky when we talk about domain. So here's an example. Let's let, I'm defining two new functions. Let's let f of x be x squared plus 1. And let's let g of x be the square root of x plus 4. And now I'm going to ask you to find this. Does the order matter here with division? Yes, right? Because think about numbers, right? 4 divided by 3, that's not the same as 3 divided by 4. Multiplication, yes. Division, no. So if you go back and you look at the 4 things we've looked at, addition, and multiplication doesn't matter what order. Subtraction and division, it does matter. So which one is going to go on top here? Square root of x plus 4, right? Because I said g is on top here, so you write square root of x plus 4 over x squared plus 1, right? Now this is where I was saying this is kind of easier because really at this point there's nothing more we're going to do with this. Okay? We're not going to try and divide this, we're just going to leave it alone, just like this. So as far as what the function looks like, that's it. But what about domain? What is its domain? So do you see a square root in there? Yes. Do you see fraction? Yes. So let's talk about each one of these situations separately. In terms of domain, what can you tell me about that square root? How did we do that? How did we attack this? We take this, right? And we want to make sure that it's what? Can you have 0 there, though?
Yeah.
You can take the square root of 0. That's okay. You just can't do the square root of a negative, right? So the way I said it last class is I want to make sure that whatever was there, that's what was there, right? Does anyone know what we call the thing under the radical symbol? It has a name. Radicand. We want to make sure the radicand is non-negative, right? Another way of saying non-negative is greater than or equal to 0, right? Does everyone understand what I'm doing? Because I did this last class and the lack of response is kind of concerning me a little bit now. When we have a square root, we have to guarantee that that is not negative, which is the same as saying positive or 0, right? Positive or 0. That was called a linear inequality, and the way we solved it was just moving the 4 to the other side, which would give us x must be greater than or equal to negative 4, right? Subtract 4 both sides. So what we're saying is, so far, in order for this function to be defined, I need to make sure that what I plug in is bigger than or equal to -4. But now I need to address the division, because I have a fraction and I have my x in the denominator. It might be possible to have division by 0. Now you tell me if it is. Is it possible for x squared plus 1 to be equal to 0? No? Why not? Yeah, think of any number. I don't care what it is. Think of any number. Square it. It's got to be positive, right? Well, what if it's 0? 0 squared would be 0. So this is going to be either 0 or a positive number. Agreed? If I add 1 to it, it's just gotten bigger, hasn't it? There's no way that can be 0. Another way you could look at this is you could say, move the 1 to the other side, and you're saying something squared is -1, right? That can't happen. So it is not possible, it's just not possible to get 0 on the bottom. Right? So I'm okay. It's safe to plug any x in here, because no matter what I use, this denominator will never be 0. So the only thing that's restricting me is this part. Questions? So my answer needs to be an interval, right? How do I say x greater than or equal to -4? It's everything to which side? This means x, right? Our answers are bigger than -4. Bigger is which way? To the right. So it's everything to the right forever. Can I be -4? Yes, right. This says right here I can be equal to -4. So I include that point. So as an interval, it's from -4, including -4, all the way out to infinity. And we're done. That's the domain of this function. All right. You're making me feel like it's Monday again. We're going to have a battle of the sexes here, okay? I'll try and be equally fair. It's kind of redundant. Let's see. All right. Let's change f of x to, well, no, I'll keep it f. I was going to say like females and men or something, but let's just say the females in this class, y'all are the f function, okay? Y'all are f. Oh, guys, okay. And the guys are, right? The guys are g, the females are f, all right? So if I put something like this on the board, what I'm saying is females, what is f of 0? Females, not males. Anyone? Which is? It's f of 0. Don't be shy. 1, right? It's just 1, right? Okay. This isn't a trick question or anything. What's g of 0? 2, right? So if you plug 0 into f, it spits out 1. If you plug 0 into g, it spits out 2, right? All right. Ladies? 5? Gentlemen?
10.
10. Okay? Yeah, nothing, no voodoo magic or anything here, right? Okay, now let's do something. If I said to find f plus g of x, you would add the two functions together, wouldn't you? Okay, so let's add the two together. I'm going to do it really fast. When you add these two together, you would get x cubed plus x squared plus 3. That's what you would get. With me? This is a new function, isn't it? Now, I would like for you, everyone together, okay, as a group, to tell me what f plus g of 0 is. Right here. It's 3, right? F plus g of 0 is 3. Now come back over here. Girls, ladies, what happened when I gave you 0? You gave me what? 1. Guys, when I gave you 0, you gave me 2. If I say add these two together, what do you give me? 3. Do you see how this function, the new function we came up with, does the work all at one time instead of separately? This is an important concept, all right, because of what we're about to do. If I plug 0 into the sum of two functions, it's the same as doing each function individually and adding those two answers together. Yes? Okay. That may seem obvious, but just hang tight. What would f plus g of 2 be? Well, let's go here and figure out what it is. 2 cubed, 8, right? Plus 4 plus 3, that's what, 15? But that's what you would have gotten had you added them together here. The same thing happens with multiplication. The same thing happens with division. The same thing would have happened with subtraction. All right? When you add, subtract, multiply, or divide, you create a new function that basically does the work independently and then puts the answer together for you all in one step. Make sense? Okay. Now let's talk about composition. We're going to come back to those functions in a minute. This is our last topic for the test. So composition. Composition. How long is the test? Question-wise, well, the review's, I think, 10 questions. But you'll have probably an hour, 15 minutes to do it. 10, sorry. I said 10, you may not have heard me. 10, the review is 10, so it'll be probably about 10. Okay, composition. There is not an equivalent to composition when you're looking at numbers. So like I was saying earlier, you're taught 4 plus 3, everyone's happy, right? You're taught 4 minus 3, everyone's happy. You're taught 4 times 3, everyone's happy. You're taught 4 divided by 3, everyone's happy, right? Everyone understands that. Addition, subtraction, multiplication, division. But there is no fifth thing, right? There's no fifth, like 4 and then some weird symbol like a triangle 3, and then we know to do something with that, right? There's no fifth operation of arithmetic. Well, with functions, there is a fifth operation, and it is called composition. So you can only do this with functions, not with numbers. And here's the way it works. Given two functions, f and g, if I write this down, f with a little o and then g in between. Right? Look, sorry, f and g with a little o between them, and then this. That tells you that you need to do composition. That is the symbol for composition. And here's what it means. It means you're going to take the f function, and inside of the f function, instead of putting x, you're going to put the entire g function inside of the f function. Now, what's it?
Really long equation.
We'll see how it works. It depends on the functions themselves, how long it is. Some teachers call this fog. I don't like, just like for the same reason I like FOIL. This is f, the way you read this is f of g of x. That's the way you read this, f of g of x. F of g of x. So I'm going to do an example with this, and then we're going to move on and see what would happen if I changed the order. I did g of f of x instead. Would it change things? All right, first example. I'm going to get some new functions up here. Let's let f of x be equal to 3x plus 1. Let's let g of x be equal to x squared plus 1. I would like for us to find not fog. I want us to find f of g of x. That's the way it would appear on a test. I wouldn't give you any more information than that right there. So what you would have to know from this is that that is equal to f with g of x inside, right? That's what you need to know. So let's just rewrite this. This is the definition of composition. Let's leave the f alone, and inside of f, let's actually write down what g is. What is g? X squared plus 1. Now, last class, you may recall when we were doing evaluation of functions, when we first started talking about functions and how to evaluate them, I gave you a function, like forget this one's here, gave you a function, I said, hey, plug in 1, and everyone plugged 1 in, right? I said, plug in -2, everyone plugged in -2, and then I said, like, plug in t or something like that, and everyone's like, huh? Just replace that with t, right? Then it was something like 2t, and then you replace that with 2t. Then it was something like 2t plus 3, and you replace that with 2t plus 3, right? What we're going to do here is we're going to take our f function, which is this one, and we are going to replace our x right here with x squared plus 1. So what would happen if I replace x up here in f with x squared plus 1? What would we get? What would that turn out to be? 3 times parentheses x squared plus 1 plus 1. And now distribute through with your 3. Does everyone see that? Notice the f went away because I'm plugging this into f, so I'm actually evaluating the function at this value. I distribute the 3 through now. I get 3x squared plus 3 plus 1, which is just 3x squared plus 4. And that's it. What's the domain of that? All real numbers? Well, we need to talk a little bit about domain here in a second, but looks like it's all real numbers. Any questions? Now, let's let the females be F, and let's let the guys be G again right here. And let me ask the females here, what's F of 0? 1? Guys, what's G of 0? 1? Now, let's come down here and let's plug 0 in here so that I'm actually asking you, what's f of g of 0? What is it according to this? It's 4, isn't it? So what the hell is that? How do I go from 1, 1 to 4? Like, what's happening here? Remember with addition, we took our 2 answers, we added them. Subtraction, we subtracted them. Multiplication, we multiplied. Division, we divide, right? We did our 2 answers independently, separate from each other, didn't we? That's not what's happening here. Something else is happening. So let's just go back to the definition of composition. If I plug some value of x in to this, which function gets that value? If I plug in an x, according to what's written here, who gets that x? G does, right? And isn't g of x, g going to do something with that? Aren't the guys going to do something with what I give them? And they're going to spit out an answer, right? And guess who gets that answer? F does. So watch this instead. I'm going to erase these. Keep those up there. All right, if I do f of g of 0, 0 goes into g first. Okay, so guys, what happens if we plug in 0? You spit out what? 1, right? Now, girls, females, what happens if the guys hand you 1? You get 4. You see? What's happening instead is the value that we plug in initially, 0, went through the guy's function first. That answer came out and went through the girl's function, and then came out as an end result. So composition is like a chain of events. If you want, you could look at it this way. Okay. This is really cheesy, and I'm sorry if I'm insulting you by drawing pictures, but sometimes pictures makes harder things. This will be a truck, okay? That's a car and a truck. We have 2 different car washes, right? You send a car through here, it comes out a car, right? Clean car. And then over here, you get the truck comes out and comes out a monster truck, right? So if I ask you to add these 2 functions together, right, then you should have this car plus this truck. So you add them. With composition, what's happening is that you actually don't have 2 different functions. It's this car goes through this car wash first. That answer comes out and goes through the next car wash. So it's a chain of events instead of 2 independent events that you add or subtract and multiply or divide. I hope that makes sense. So will it matter if I go the other direction then? In other words, if I try and plug that, in the one we just did, I plugged in the value to G first, that answer then went to the F, right? What if I take that value and put it in F first and then pass that over to G? It should be different. Will it always be different? It's something to ponder. So what were my functions? It was 3x plus 1, right? And x squared plus 1?
Yes.
Okay. So I want us to now find g of f of x. So by definition, this means g has f sitting inside of it this time. See the difference? Now replace f of x with what f of x is. What's f of x for us here? 3x plus 1, right? Now 3x plus 1 needs to be plugged into the g function for x. So you're just passing this into g now for x, which would become what? I'm going to square it, right? So I'm going to take that whole thing, 3x plus 1, I'm going to square it, and then I'm going to add 1. Now let's see what would have happened had I done g of f of 0. According to this, what happens if I plug in 0 in through this composition? We get 0 here, it's 1 squared. 1 plus 1 is 2. We should get 2, right? Let's just check that we can see like kind of what happened here. Which function got 0 first? Which function gets 0 first? F. Okay. Ladies, what happens if I give you 0? What do you spit out? 1. Take that answer, 1, and send it through the guy's function. What do you get? You get 2. You see that? I have one more picture to show you that might help us see this. In the first example I did just a second ago, we plugged in 0. It went through G first and came out as a 1, and then that went through to the F function and came out as a 4. Do y'all agree? That's what we did previous to this. Just now, I plugged 0 into the F function first. That actually came out to be 1 again, but then when that goes through G, it comes out to be 2. Okay? Do you think it's possible that you could have a function that it doesn't matter which way you send it through? Like, if, let's say, I send 0 through and it comes out, it goes through both and comes out 4, that if I do the other way, it comes out 4 also. Do you think it is possible to have functions that behave that way? Yes. It turns out that that's the way we define a function's inverse, which we'll talk more about. But it's a function that undoes a function. So you have a function that maybe cleans a car, then you have another one sitting there that throws all the dirt back on it, you know? It undoes what the other one just did. But that's beyond what's going to be on this test. All right, well, how about this? Same two functions. How many of you had heard an instructor tell you like fog and golf? Fog golf? Fog golf? No? Fog golf? No? No one's ever heard that? Okay, then I don't want to be the one to say it. Forget that I ever said that. The reason why is because it doesn't make sense to have this. Think about what this is saying. By definition, we're going to take G, and inside of it, we're going to put what? G. Right? That means we're going to pick some value of X, we're going to send it through G, right? It's going to come out. And then what do we do with that? Send it back through G. So it's like a double car wash. You know, you go through, you get clean, you come through, the second time you get cleaned again, even better. So what would happen in this case? We would have G, and then we replace G with what G is. What is G? X squared plus 1. And now if I ask you to plug x squared plus 1 into x squared plus 1, you're going to replace the x with x squared plus 1. So it looks like this. X squared plus 1 squared plus 1. So that's your x squared plus 1 being plugged in, so it's squared plus 1 again. So out of curiosity more than anything else, what would g of 0 be? According to this, it would be what? According to this, if I plug in 0 here, I get 1, squared is 1, so I should get 2, shouldn't I? Okay, so plug 0 into this. What does it give you? 1. Take that answer and plug it back in. And you get 2. All right. One last one. Let's see if I can push you to the limit, if I have not already done so. Same two functions, okay? Same two functions. Find nobody ever said we only had to have composition of 2 functions. It could be 3. What do you think this means? So I don't know if you've noticed, I've been reading this from the left to the right. So I'm starting off here, I'm saying F, and inside of F is what? G, but inside of G is what? F of X. So what's going to happen is X first goes into F, right? And then that goes into G, and then that goes into F again. F of g of, what was f of x? 3x plus 1, right? So I've replaced this with this. What happens when you take 3x plus 1 and plug it into g? I'm running out of room here. F's still sitting here. What happens when you take 3x plus 1 and plug it into g? Wasn't it this? Wasn't that it? What was the function g? Wasn't it x squared plus 1? So isn't that, I'm plugging in 3x plus 1, that's our x squared plus 1. Now where does that get sent? It's sent into f, right? This whole thing is going to go into the f function for x. So that will become 3 times, this is what f looks like, right? 3x plus 1. But what's x for us this time? All that, right? 3x plus 1 squared plus 1. Now, I'm kind of pushing the limit, I think, here a little bit, just by looking, but
Is it easy to simplify 3x plus 1 at the beginning so we get the actual, the whole equation?
how do you mean?
Like, well, you don't like to FOIL, but you actually do FOIL it,
Oh, you could have done all that.
it just gets a bonder, but
Yeah, you could do that. In fact, everyone in here should be able to, at this point, expand that out. You would get 9x squared plus 6x plus 1, and then you'd add that 1, you get 2. Then plus 1, then you distribute the 3 through, and then you get this big old thing, yes. But this is fine on a test. You can go here or you can go further. And maybe if you did in the beginning, it might have been easier to do it that way. Depends on you. Okay, functional composition. Y'all look thrilled. Thrilled. So we've been here for an hour, 15 minutes, or 18 minutes. What we'll do is let's take a break, and then we'll come back and we'll do the review, right? Pause this video. All right, so you have the review here, and we have a couple of options as to how to approach this. I mean, I could just sit up here for the next hour, 15 minutes and do the whole review. Or I could let you take it home, let you work on it, and then provide the answers to you via Canvas, post the solutions. I could let you work on it right now on your own and answer questions as you work through it. It's really kind of up to you what you think would be best for you. So what do y'all think? What do you think would serve you best? Take it home. We have one vote to take it home.
I'll take it home.
See, I've done it different ways. I've sat here and I've gone through the entire review and I've showed exactly how to do every single problem. And I've let people take it home and do it on their own. And there's usually absolutely no difference between the performance that I get from the class. If I show you how to do it all, I don't think that'll make as much of a difference. It's all going to come down to you. If you can do problems like this, test is going to be no problem for you. Okay? The test is, I always give partial credit as long as you're showing your work, as long as I can tell what you're trying to do. If you make little mistakes, if I can tell where those are, I give you some credit. All right, so every problem I grade pretty much on a 10-point scale. Everybody starts with 10 points, and I take off if things are missing. All right?
you take off if you get the right answer, but
I have to see work. Now, if there's no work and you have the right answer, I won't give you credit. Unless it's something very trivial, but let's see, like 5A, okay? That is somewhat trivial, just plugging -3 into the function. So if you do that in your head, and that's fine, all right, if you have the answer. But if it's wrong and there's no work, It's all wrong. If you show your work and I can see, oh, when he squared -3, he forgot the negative in front there, I can see that, and so I'll take off some but not everything. So I always encourage you to show as much work as possible. What are you allowed to bring to the test? Of course, you can have a calculator. You cannot have your phone, right? So no excuses on Thursday. Have to have a calculator. I am recording that. Yes, I did record that. And I will let you have one sheet of paper, 8.5 by 11. You can write on the front and the back. You can put anything you want on that sheet of paper, except worked out problems. So you cannot just take all these problems, work them out on a sheet of paper, and use that as your cheat sheet on the test. Your cheat sheet can have any formulas like all, y equals mx plus b, y minus y1 equals m times x minus x1, m equals y2 minus y1 over x2 minus x1. All that stuff, you can put it on your own sheet of paper. What I suggest you do is work through the review, and as you need formulas, as you're going through your notes or your book or watching videos, start writing down the things that you need. You can write down steps on how to do things like number 2, right? Determine, it's supposed to say if these lines, there's a couple of typos in here, if these lines are parallel, perpendicular, neither. So if I was writing a note to myself, I would say something like, to check perpendicular, parallel, neither, find slopes of each line, right? How do you find slope of each line? Solve for y, right? Y equals mx plus b. Find the slope. M is your slope. Compare the slopes. If m1 equals m2, they're parallel. If m1 times m2 is -1, they're perpendicular, right? These are all things that are in the notes. You just have to put the effort in to kind of get that onto a piece of paper. You okay with that? Understand? If you come into class on Thursday, class is going to start at 2 o'clock. If you walk in here and you don't have your cheat sheet, you cannot take 15 minutes of the first part of the test to make your cheat sheet. All right? Your cheat sheet needs to be done at 2 o'clock and ready to roll at 2 o'clock when the test starts. All right? What else? Anybody have any friends in the class yet? Anyone, y'all going to do any study groups or anything? This first test is important. This is, I promise you, this is the easiest test we're going to take in terms of material. This is the one you want to start on the right step with, all right? Okay? I don't mean that in a bad way. I'm just, this is your chance to really get started in a good direction. You don't want to dig a hole right now. So I encourage you to make, maybe form some groups, get together, study. I'll be in my office before class. But you can't expect to walk in on Thursday at what is it, 11:30? No, 12:30 when I'm there, and be like, okay, I'm ready to start the review. It's just not going to work. Okay, you need to put a couple of good, hours into this. Go back and review your homework. So let's do a vote, a final vote here. 1, I stay. I go through the whole review on video. 2, I let you go. You do it on your own. I provide the solutions online. Now, I will try and do video solutions, which means I write out all the solutions, and then I do a video of me talking through the solutions, like explaining what I'm doing at each of the steps. I will try to do that, but I can't promise it. I will provide answers, but as far as the video with all the answers, no guarantee.
What answers now? Step by step.
The answers will be step by step. Yes. So, okay. How many of you want me to work it all out on the board video right now? Don't be afraid to say it. You're already tired of me. Okay. How many of you are ready to go home and do this review on your own? And knock it out. Yes? Okay, that's a majority, easy majority. Let's see. I do need to talk about number 1 because we never did anything like number 1. So let me talk about it. I have here, Katie sells perfume at the mall. She makes $40 a day plus $6 for each perfume she sells. Find a linear equation which connects, that's supposed to say Katie's, not K's, Katie's daily income to the number of bottles of perfume she sells. Sketch the equation. So let's talk about what you're trying to find the equation of. The equation is supposed to connect her daily income to the number of bottles she sells, right? So why don't we call, let's let Y be equal to her income, and let's let X be equal to the number of bottles she sells. Right? Then Y is equal to, well, how much does she make per day? $40 plus $6 per bottle. So if she sells one bottle, it's 6, 2 bottles, it's 12. So this should be 6x, shouldn't it? And then just rewrite it as Y equals mx plus b. And you have a linear equation, don't you? Now there are some things that I would expect to see if you did this on a test. I would expect for you to identify which variable is which. Make sure you say Y is her income, X is the number of bottles. And then I ask for you to graph it. So to graph this, you would have to go up 40, right? Up 40. So let's count by 5s. 5, 10, 15, 20, 25, 30, 35, 40. That's my y-intercept, right? And then to get to another point, I use the slope. So up 6 over 1, right? So if this would be 45, up 6 would put you a little bit above, like somewhere around there, and then to the right 1. Now, just because this is 40 up doesn't mean that this has to be, 40 this way. This could be 1, this could be 2. This is called changing the scale of the axes. So as long as each tick here is worth 5, that's fine up and down. Your tick marks left and right don't have to be 5 each. So I've changed it, that's 1. So I go up 6 over 1, and then I draw a line like this. Now why did I draw the line like that and not come this way with it? She can't sell negative bottles, can she? Well, I guess so. Drop them all on the floor, then she owes them something, but we won't talk about that, right? That makes sense? Okay. All right, number 2, I'm not going to work through these. I already talked a little bit about 2. You compare the slopes, right? Number 3, find the equation of a line which is parallel to a line, but through a different point. I did that last class. Actually, I did parallel, and then I did perpendicular. I did them both. So on your test, be ready for either one. I could say find the equation of a line parallel to this one or perpendicular. Number 4, domain. A, you have to worry about division by 0. B, you have square root. You have to worry about that. C, C's a line, isn't it? No issues with domain. 5, all you're doing is plugging those things into the function. Yes?
Are you saying what found our work? Like on 4C, would we really need to?
On 4C, no. Number 6, sketch the following and list out the transformations. At the very end of that, there's a brace. Just, again, I don't know what happened. It's supposed to end after the 2. So there's some shifting of things, and you need to know, toolbox functions. You might want to put that on your sheet, right, if you can't remember them. Number 7, another shifting transformation problem. All right, number 8 is what we did today. G minus F, F times G, F of G, G of F. So I'm only asking you there for subtraction, multiplication, and then composition both ways, both directions. Number 9, factoring. Remember we started this class with factoring? There's not a whole lot of factoring here. But remember the steps for factoring. GCF first. How many terms do you have? Right? You may have difference of squares. AC method, grouping, right? Those are the main things. Number 10, which of these are functions? Can you tell me which of those is not a function? A, right? Fails a vertical line test. B, C, and D are all functions. Can you tell what the domains and ranges are? Okay. All right, at this point, I will officially let you go, but I'm going to cover something that's a bonus type problem. Right? You don't have to stay, is what I'm saying. It won't take, I think it'll take maybe 5-10 minutes. Some people like bonus, so this is a random, kind of a random topic, but I always like to share this with my classes. Does anybody know what 1 plus 2 plus 3 plus 100 is? You understand what I'm asking, right? 1 plus 2 plus 3. Like, you get on a calculator and probably do that after a while, right? As long as you don't mess up, right? Accidentally mess up. Okay, so there's a story about a very brilliant mathematician that when he was in first grade, the teacher gave them that problem. This was like in the mid 1800s. Okay, and so this little first grader was given this problem by the teacher, and within a few minutes, the student, his name was Frederick Gauss. He had finished his problem. He had actually worked on it, and then he turned over his little sheet of paper, whatever he was writing on, and just sat there, very quiet and disciplined, because they had that back then also. And so he sat there. And the teacher went up to him, and Gauss had this written. N times n plus 1 over 2. And the teacher looked at Gauss and said, you know, who showed you that? And let me tell you what the formula is first. The formula works like this. If I want to stop at a number, right? Like, let's say I want to add up the first 4 numbers. This last number is n, okay? Gauss was saying that all I have to do is take the last number you want me to add up, n, multiply times n plus 1, and divide by 2, and that's going to be the correct answer. So let's just check, check Gauss's work here. What's 1 plus 2? 3 plus 3 plus 4 is 10, right? Now take 4 and plug it in over here and see what you would get. 4 times what? 5, right? Over 2, that's 20 over 2, that's 10, isn't it? So it worked that time. Would it work every time? Well, yes, it turns out it does. So the formula was known, okay? You see how the formula works? So if I want to go to 100, I just do 100 times 101 over 2, and that's the answer. So the formula was known. The teacher looked at it and said, Gauss, you know, Frederick, whatever his name is, who showed you that formula? And he said, you know, nobody showed me that formula. I just came up with it. So the teacher didn't believe him and thought he was lying and everything. So Gauss went on to explain how he got that formula. So let me explain to you how this first grader got this, okay? See if you can follow this. Let's just start with this, okay? Let's say that this is what I want to add up, right? And let's just call it, for the sake of respect of Gauss, let's call it capital G for Gauss, okay? That's capital G. Now, Gauss realized that when you add numbers up, it doesn't matter what order you go in, right? So he said, I could write that list backwards. And let me add some numbers here. 97, 98, 99, 100. So I come down here, and this would have been 1, and then 2, and then 3, and 4. Y'all see that? So that's just the list written backwards. And Gauss realized that if I take the 2 lists, or he realized if he took the 2 lists and added them together, what's G plus G? Well, that's 2 G's, isn't it? And if I add these lists together, look, add straight down, what happens here? What's 100 plus 1? 101. What's 99 plus 2? 101. What's 98 plus 3? 101. And that's going to keep happening all the way down the list. Right? See that? So Gauss said, look, I have the same number appearing here, right? And then he realized, well, how many of them do I have? How many of those 101s are there? Well, there's 1, 2, 3, 4. There's 100 of them, right? So he realized that 2G is 100 101s, right? Yes? And then divide both sides by 2, and you have what it should be, right? Now, are you agreeing, or do you follow that? Okay, all right. All right, so what Gauss, but see, I kind of lied a little bit, because Gauss was actually even smarter than this, because he didn't do it for 100. What he realized, what he told his teacher, is that to get his formula, I showed you that so you could see this, that if you went out, and let's say you added instead of to 100 to n, wouldn't the one right before it be whatever n is minus 1? And wouldn't the one before that be whatever n is but take away 2? So like that's 100, that's 99, and that's 98, right? And if I write that list backwards, then it's n plus n minus 1, and then this one is n minus 2, and then you go all the way down, you should have what, 1, 2, and 3 here, right? And then Gauss said, I call that G, and now I add straight down, and I get 2G is what? What's this first one added together? Added. 1 plus n, or n plus 1, isn't it? What's the next one? What's n minus 1 plus 2? N plus 1 again. What's the next one? What's n minus 2 plus 3? N plus 1 again. And then I keep doing that until I get to the very last one. What's the last one? N plus 1. How many n plus 1s are there? 1, 2, 3, 4, 5, 6, blah, blah, blah. How many of them are there? N of them, right? So this right side is n plus 1s. And now divide both sides by 2. And you have the formula. So how many of you kind of followed that? Okay? So the reason I like to give this example is because I think for the most part, most people can kind of see what Gauss did, especially when I did 100, right? And so I like to show it to you because I think that this is a very good example of what separates geniuses from just us normal people. At least this is mathematical genius, right? This is a first grader who's extrapolating this idea on his own, right? Once you see it, it's not so bad, right? But it's the seeing it that's the challenge. And that's what makes, a genius something you have to appreciate. So he went on to do a lot of really great things in math, needless to say. So how could I possibly ask you a question on the test? As a bonus, perhaps, would be just to ask you to do something like this. Find 1 plus 2 plus 3 all the way out to something achievable, like 673. So what would that be? You break out your calculator, don't you? 673 times 674 over 2. Who's got it? Anyone? Some number? $226,801. 226,801. That's it. That's what would happen if you add these up. Another way you could look at it, what if you lived to be 100, right? Then that's how many birthday candles you've had on your cakes, right? 1 plus 2 plus 3. It adds up integers. And it turns out there's other formulas that you can use if you want to add up like perfect squares. Like this is 1 plus 2 plus 3 plus 4, but there's formulas that we have that add up 1 plus 2 plus 4 plus 9 plus 16, right? Those are perfect squares. Sorry, 2 doesn't belong there. That's 1 squared, 2 squared, 3 squared, 4 squared. We have another formula for that. We can add up perfect cubes, things like that. So, all right. Adios. Have a good day. Do the review. Today or tomorrow. Don't wait till Thursday morning.